All right. I wonder if the camera still doesn't work. Yeah, it still doesn't work. It's too bad. Okay, so we're actually going to start by looking at questions 15 and then 13. Those two are the really long questions. And it's kind of deceptive because there is a whole bunch of things that you need to do that are not explicitly asked for. Okay, so we see with 15, the price of gas at an SRS of 10 gas stations were recorded, sounds like bad English, during 1 week period. Prices are in cents per gallon. Check conditions and construct a 92% confidence interval for the average increase in price. Based on your interval, can you refute the claim the average gas price increase was 22 cents per gallon? So, two things to do here, or two big tasks. First big task is that confidence interval. Second big task, which turns out to be not that big, is to answer the question, does our data support a 22 cent per gallon increase? Two things we need to do. Okay. Maybe we should close that. Thank you. You know, Justin, I've always wanted an In-N-Out t-shirt.
It really is probably my favorite Christmas present.
Was it?
Yeah, actually.
There was a precisely... No. Never mind. That's a dumb story. Okay. First question we need to ask ourselves is, what kind of an interval do we need to make? There are two varieties, and if you pick the wrong variety, it'll be catastrophic. Okay? And I mean that, catastrophic. So the first question, this is really the same question 3 times. Are we talking about a mean or a proportion? Which you could also ask, are we talking about mu or pi? Are we talking about x bar or p? X bar. Of course, all 3 of these things kind of work together. So you're going to have to get used to reading and figuring out that whether or not we're talking about mean or x bar. One good thing to think about is, are we counting things or are we computing measurements? Okay. Well, this is a bunch of measurements of gas prices. So that kind of signals to me that we are talking about a mean, like you're all saying. Okay. So, next, what do we do? We're going to go through those 3 steps. Steps 1 and 2 are pretty easy. Step 3 will take a while. Let's take a look at step 1 and 2. Firstly, since we're presented with actual data, you're going to want to put that data in the calculator lists. Okay. Now, as I'm reading the question, the price on April 15 is not actually important to the question. Well, it's important, but it's not what we're using. The price on April 22nd, likewise, we're using it, but it's not what we're going to compute an interval for. We want the interval for the average increase. So we need to calculate increases. List 1, I have April 15. Yeah. List 2, we have April 22nd. List 3, I'll do this again. I'm going to clear it off first. But list 3, the question is the increase going to be April 22 minus April 15, or is the increase going to be April 15 minus April 22? April 22 minus April 15. So that's going to be list 2 minus list 1. That'll give me all of the increases. Now that I have the increases, I really don't care about list 1 and list 2 anymore. I could clear them off if I really wanted to, but I'm going to leave them there for now. Okay. List 2 minus list 1. After minus before. Okay, so what can we tell from this list? Well, every gas station had a price increase. This gas station looks like they're gouging. So does this gas station. This gas station is probably United Oil.
Or Costco.
Or Costco. Yeah, probably closer to Costco. Yeah. Okay. We are now going to have to figure out a few things. Namely, if you take a look at the work here, we're going to have to calculate X bar and we're going to have to calculate S. So let's do that right now. On the home screen, if you don't remember how, stat, calc, 1var stats. And that's really important now that we choose the correct list because we have 3 to choose from. We want the stats for list 3. So I'll put L3 there. I'll leave the frequency list blank. Push enter. And there we go. First line is the important line. X bar is 14.9. Okay. This one over here, SX, that's my standard deviation. I want to use SX because we are looking at a sample of gas stations and not every gas station in Southern California. Okay, so we have those numbers. We're going to take them down, which I guess means write them somewhere. And then we'll go to our work. Okay, first one. What is mu x bar? Mu x bar is approximately equal to x bar, which is equal to 14.9. This says that the mean of the sampling distribution is the same as, is going to be approximately equal to the mean of our sample. Number 2, sigma x bar is going to be S divided by the square root of n. This says that the standard deviation of the sampling distribution is approximately equal to standard deviation of the population divided by standard deviation divided by the square root of the sample size. Except for we don't have sigma. We don't know the standard deviation of the population, so we're going to estimate that with S. This S here is taking the place of sigma. Okay? 9.219 divided by square root of 10 gives me 2.915. Okay. Conditions. How come this standard deviation formula works? Well, it's only going to work if we have less than 5% of the population in our sample. Am I told how big the population is? No, I'm not. No, I'm not. So this is where there are some assumptions you need to make. Okay. We don't know if it's true, but we have to pretend it's true. So Is our sample less than 10% of the is our sample of 10 gas stations less than 5% of the total number of gas stations? Well, yes, there should be more than 200 gas stations. And I think if you think about that a bit, it seems like there are more than 200 gas stations. Where does that 200 come from? Well, 10 is 5% of 200. You do whatever math you need to figure that out. Yeah.
You have to explicitly write that.
Yes.
So we have to write 10 is 5% of 200 and there's more than 200.
Yeah. Okay. Steps 1 and 2. Any questions? Step 3 is a bit of a bother. Yeah.
Is this type of question going to be like broken into multiple choice?
No.
Ever?
Multiple parts, you mean?
Yeah.
No, not usually.
Okay.
It can be, but mostly not.
So it's going to be just like that right here.
Yeah.
Wait,
Yeah.
so, the standard deviation you use SF?
Yes.
And why is that?
You use S if the numbers in your calculator is a sample.
Okay.
Okay, step 3 is the normality condition. We need to check to make sure we can use a t-distribution. Okay. Now there are 3 things that could happen. These are arranged from easiest to most difficult. So the first thing you want to check is the easiest one. Very easy. Is a sample greater than 30? No. Okay. If the sample was greater than 30, then we could say the CLT theorem, the central limit theorem. Oh, I just said central limit theorem. No. The CLT, if the sample size is greater than 30, tells us that the sampling distribution is approximately normal. Since that's not working for us, we have to go on to number 2, which is just as easy as number 1. Number 2, is the population of gas station increases. Do I believe that the gas station increases are approximately normal? Thank you. And for this one to work, they have to pretty much tell you that. And they don't tell us. They don't tell us that the gas station increases are approximately normal, so we can't use number 2, which dooms us to number 3. Okay? Now we have to use number 3. Luba. I don't know why I said that all weird. Summons for superlative. You're possibly a superlative.
I look like such a bum. Are you serious?
Thursday.
Okay, thank you.
Do you see when, what's that?
Okay. Okay, so we can use the t-distribution if we believe if the sample is reasonably single-peaked and no outliers. Okay? So firstly, look at the histogram. Okay, let's look at the histogram. Stat plot. Plot 1. Turn it on. Change the type to histogram. Which list am I interested in? List 3, good. List 3. Go ahead and get your calculator to look like that if you're playing along. Okay, now that I have that, I'm going to go to Zoom and Zoom 9. That's going to give me a histogram. Now, it's not important for you to actually copy the histogram. You can just look at it, which means that you don't have to humanize anything here. You can just look at it and say. Is this approximately single peaked?
Yes.
Is it reasonably single peaked? Yes. This is reasonably single peaked. Is it symmetric? No, it doesn't look symmetric. But the single peak is what we're really looking for. This is single peaked. Right skewed. Right skewed. This is right skewed. Single peak though. Okay. It looks right skewed. Sorry, single peak. And the single peak part is the part that's really is what we're really important in the third one. Next. Or do you all have that single peak? You're looking for single peak. Next thing you're going to do is you're going to look to see if there are any outliers. The quickest way to check for outliers is to look at the box plot. Okay. I don't think there's any one of you who wants to compute the IQR, multiply that by 1.5, add that to Q3, and then subtract it from Q1, and then analyze the data to see. No, I don't think any one of you wants to do that. So the box plot is the quickest way to do this. Let's go back to stat plot. Go back to plot 1 and change the type to box plot with outliers. You can tell this is box plot with outliers because it's a pictogram of a box plot with outliers.
Wow.
You laugh. Someone's going to ask me which one is the correct box plot. I mean, there's so many other things we could talk about.
During the test.
Yeah, Baram.
89, is it modified box plot?
Yes, it's modified box plot. Okay, we got that. X list is still going to be L3. Frequency, always leave it as 1.
What happened if you go to?
Yeah. Let's zoom. Zoom. Zoom stat. Okay. That's not bad, right? That makes it look like it's single peak close to symmetric, doesn't it? But the important thing here is no outliers. So we're going to note that on our work. Box plot does not show outliers. Lastly, how about that normal probability plot? Is that approximately linear? Again, go back to stat plot. Plot 1, change the type to normal probability plot. Normal probability plot is the one that looks like a normal probability plot. Just kidding. They all look. That one's hard to tell, but it's the very last one. When you push enter, the options will change. Make sure you have the correct data list. Make sure you have the correct data axis. I like to put it, the data axis on Y. I like the square mark so your eyes don't go blind. I mean, what kind of person's going to use the very smallest marker?
Let's make a very detailed picture. It blended.
Zoom, stat, and you're looking for linearity. Does that look like a straight line?
Yeah.
Good enough, right? Okay, normal probability plot is approximately linear. And here's our conclusion. The sample does not contradict normality. T-distribution is safe. T-distribution is not safe if you see contradictions to normality, namely outliers. Yes.
So because we found that the box plot shows no outliers, doing the normal probability plot, it would serve no purpose. Because only one of those has to be true.
Yeah, kind of.
Okay.
It's a weird thing.
So do we only try one of them?
You need to make mention of all three.
Oh,
If one of them contradicts,
Yeah.
it, then you can't use teach distribution, just one of them doesn't work.
all of them have to be true.
They all should be true. But the only thing that will really damn you is having an outlier. Okay? It doesn't really matter since you're going to continue the problem even if you fail. Right? Don't stop the problem. Just keep on going. Good note here. There are three things that you could have done for normality. You only need to do one of those three. Give me 1 second, Jake. You either do 1, ignore 2 and 3. You do 2 and ignore 1 and 3. Or you do 3 and ignore 1 and 2. Now, I have to go through all three of them because we're reviewing. But when you take the test tomorrow, or Thursday, you only have to do 1, 2, or 3. You don't have to do all three. Okay? Whichever one is applicable.
What's the CLT stand for?
Thank you. Mr. Ferreria, they said we just need to mention all three. I'm good.
No. 1, 2, or 3.
Oh, so you
Maybe I should say 3A.
so do we have to mention A, B, and C?
Yeah.
Okay.
3A, 3A, and if you do 3, you have to do 3A, B, and C. If 1 is applicable, then you don't have to do 2 and 3.
So it just depends on the information given.
Yeah. If the CLT applies, then you say the sample size is greater than 30 and demonstrate, like 100 is greater than 30. Therefore, the central limit theorem says that the sampling distribution is approximately normal. And then you don't do 2 and 3. Good questions. Anything else? I know it's really confusing, or it can be confusing if you've never done this before. Okay. That's actually the hard part. The rest of this is really easy. T star. How do I get T star? Inverse. Is this going to be inverse norm or inverse T? Inverse T. Good. Let's go to program. Look for my inverse T. Mine says new inverse T. Yours is going to say inverse T 83 or inverse T 84. New inverse T by yours truly. Confidence. What's my confidence level? 92. What a weird confidence level. What's my degree of freedom? How do I compute degree of freedom? N minus 1. What's this say? Quit. Program? Inverse T 84. One. Enter. 0.92. It'll work? Okay. 0.929. That gives me that number that you saw. Right now. There we go.
What's the inverse norm for the other one?
What's it?
The inverse norm for the other
We're going to do that.
one. Okay.
We're going to do that next. Okay, 1.973. I think that's the same number I have here. Yeah, it is. Degree of freedom 9. Please write those numbers down. Next thing, margin of error is equal to the t star times sigma x bar. Gives me 5.7513. Next, we're going to write our confidence interval. First, we'll write the confidence interval as the plus and minus notation. Then we're going to write the interval as an interval. And then you're going to write down your conclusion. Conclusion. We're 92% confident that the average increase in gas is between 9.15 cents and 20.65 cents. Awesome. That's the first part of the task. Second part of the task. Does our data support a 22-cent price increase? Well, 22 cents is not inside our interval, is it? No. So in other words, most likely 22 cents is not the average increase. Okay. If we're 92% positive that the average increase is a number between 9.15 and 2.65, that's kind of like saying we're 92% confident that the average increase is not 22 cents. So our data does not support a 22-cent average increase. This is hard for some people to really wrap their head around, because you're not saying that the average increase is not 22 cents. I mean, it could be 22 cents, but you're saying the data doesn't support that. According to my data, the average increase needs to be a number between 9 and 20. Or should be a number between 9 and 20. Okay. And with that, we're done with question 15. It only took us most of the period. Any questions? Yeah. I have no doubt that there are some people out there where their test is one question and this is it.
That's a failed test.
Yeah.
How many questions is there?
10 and 2. Free response is going to be a 2-part question and a 3-part question.
Oh.
Okay? Yeah.
For the second, little paragraph after the first sentence, do you have to write, the IE and, all of that? Or can you just say, it is not in our confidence interval
Yeah.
and that our data doesn't support it?
Yeah, that would be enough. Okay, let's look at 13. 13 is actually a little bit shorter. Okay, this is about a proportion. So let's see 13. The U.S. Forest Service is considering additional restrictions on the number of vehicles allowed to enter Yellowstone National Park, as they probably should. To assess public reaction, the service asks a random sample of 150 visitors if they favor the proposal. 89 say that, yes, we support the proposal. Construct and interpret a 99% confidence interval for the proportion of visitors of Yellowstone who favor the restrictions. Okay. The question that needs to be asked before you begin any of these works, are we talking about a mean or are we talking about a proportion? Proportion. Okay. Which is like the same thing. Are we measuring something or are we counting something? We're counting. We're counting. How many people are in favor? See the difference? Okay, 3 questions. I kind of put them out of order. Question 1, what is mu pi? Mu pi is approximately equal to p, which is 89 out of 150. What is sigma pi? Sigma pi is the square root of pi times 1 minus pi over n. This calculates out to 0.0401. Number 3. Is the sampling distribution approximately normal? Well, there's only 2 equations to check. First thing to check is what is n times p? It's 89. Is that greater than 10? Yes. What's n times 1 minus pi? 61. Is 61 greater than 10?
Yeah.
Yes. Since both of those are greater than 10, we can use normal procedures. Normal as in the normal distribution. That's so much easier than means, isn't it? Proportions. Gotta love proportions. So much easier. Okay, let's figure things out. First thing, what is our sample size? 150. Second thing, what is z star? Well, let's do that. Z star comes from the inverse norm or from this wonderful program called inverse norm. Number 9, inverse norm. That guy does a lot of work. Are we talking about an interval or a test? We're talking about an interval. What's our confidence level? 99.99. What's nice is you don't need a degree of freedom. Also, this program is really good because you don't have to worry about, well, it would be 0.99 minus 1 minus 0.99 divided by 2. And then the confidence, you would get a z that's negative, and this takes care of all of that for you. It's just positive 2.576. No more making those mistakes. All right, there's my z. What's my margin of error? It's z star times sigma pi, which is 0.1033. Ooh, 10% margin of error. That's huge. If that's my margin of error, tell me about pi. Pi is going to be p plus or minus margin of error. Write it as a plus and minus notation. Then write it as an interval, 0.49 to 0.6966, almost 70%. Finally, write that as a conclusion. We're 99% confident that the proportion of guests that favor new restrictions is somewhere between 49 and 70%. Awesome. We're done. Well, we would be done if I wasn't such a good teacher. No, just kidding. Let's take this one step further. Does our sample tell us that the patrons of Yellowstone favor the new restrictions? Most likely, but no, it doesn't. Okay. How come I can say no here? Well, all I know for sure is that the proportion of people that favor the restrictions is somewhere between 49 and 70%. So, is it possible that only 49% of patrons support? Yes, that's possible. Is it possible that, 65% of patrons support? Yes, it's possible. Is one of them more likely than the other? No.
Supporting this, isn't it?
No. No, it could be anything in there. Okay.
Yeah, but wouldn't 50 or greater be more likely than 40?
No. Because
Can I get Becky's stuff?
yeah, the proportion that support is a number already. It's not more likely to be one than the other because it is something already. Hold on. It's already set. We just don't know what it is. Kind of weird. Okay, so let me finish this. So since it's equally likely that the proportion of people who favor restrictions, wait, hold on. Since it's likely that they favor or they don't favor, namely since 50% is inside the interval, we can't really say one or the other. Or our data doesn't support one or the other over the other. If the entire interval was less than 50%, let's say from 38 to 45%, then we can say our data says that the patrons do not support the restrictions. If the entire interval was above 50%, let's say 55% to 65%, then we could say that the patrons or data supports the patrons like the restrictions. But it's some of some and some of the other. And it doesn't really matter that it's 49 to 70 or if it's 40 to 52. It doesn't really matter. As long as it's some positive, some negative, then we're done. Okay? Last questions on 13, and then we're going to wrap up. We're starting today at 3:30. I have to be out of the room at like 4:50. So we should know that. We're going to try and get started right away. Julia?
So can you use T star when it's mean and Z star when it's proportion?
Perfect.
Oh,
Wait, repeat that?
Yeah.